This video is going to be for those who are looking to go into something space related, but it'll really only focus on the physics aspects of that space research. Now, if you want to put things in space like rockets and satellites and work for SpaceX or something, then obviously aerospace engineering would be an ideal choice, but like I said before, many engineers in other disciplines work on spacecrafts besides just aerospace engineers. But this video is more for those looking to go into things like astronomy or astrophysics as a career. I'll go over some research going on in the field, how to get into this field, and what the job outlook is like. First, if you want to work on space research, the best two majors are probably astronomy and astrophysics. Other majors, even like chemistry, can do work in space-related things, but again, these are two of the most common. But when it comes to undergrad, usually you just go into physics to start out. Many schools don't even offer astrophysics or astronomy as an actual major. Some do, and some will have maybe a minor in astronomy or something like that, but often you start with just physics and pick a more specific discipline in grad school. This is also recommended by many people because physics covers a broad range of topics, and if you decide against space-related stuff, then you still have a physics degree which does apply to many jobs. But after your undergrad, you need to get a PhD. To become an actual astronomer or astrophysicist, this is pretty much a fact. There really aren't astrophysics or astronomer jobs for those without PhDs. In 2010, about 91% of people who actually worked in astrophysics had a PhD, and most of the others had a master's. So if you are just about to graduate high school, be ready for 9 or 10 more years of school possibly. 4 for undergrad, then 5 or 6 for a PhD. And this number is going to be different for each person though. But there's a lot of work to come. However, after your 4 years at undergrad, you will likely get a stipend and have the school pay for you to go. You won't be developing a nice savings, but you shouldn't be acquiring tens of thousands of dollars in debt either. Now, probably the biggest question everyone asks is it worth it? Are there jobs as an astrophysicist or astronomer? And I reached out on various sites to people with these degrees and a few who I knew so I could get multiple answers, and here's what I found. Most astrophysicists or astronomers just stay in academia and work at colleges and universities. They work as professors, but they also do research. As a professor, you could focus more on teaching or more on research and teach less. It just depends on you and the school. But just realize that many professors aren't just teaching. That's not what the job is all about. Like when you hear that MIT researchers discovered the next big thing, that's often grad students and professors. Those professors would be the ones leading the project, and that's where your career could go. Then astronomers and astrophysicists can also work for the government. The most famous organization would be NASA, but there are many others including Fermilab, CERN, Lawrence Berkeley National Lab, JPL or Jet Propulsion Laboratory, the Herzberg Institute of Astrophysics, which is located in Canada, and many more. If you look up national labs, you'll find a lot of them. But these are the places where they're doing things like particle research, or using particle accelerators and detectors to learn how particles interact so we can better understand the fundamental laws of nature, or they're developing computer models to explore how black holes interact with celestial bodies so we can learn more about gravitational waves. There's way more these places work on, but these were just some examples. Now the thing is, these jobs are competitive. There are more people pursuing these PhDs than there are jobs becoming available. It's hard to quantify exactly how difficult it is because it's not impossible, especially after getting a PhD, but getting a tenured teaching position to do research or a government position at these labs is not a guarantee. But getting a PhD in astrophysics or astronomy will teach you a lot of useful skills which can lead you into various other career paths. Astrophysicists and astronomers who don't go into their field directly after a PhD have found jobs at tech companies like Google and Facebook in software development because they do have exposure to computers and programming. They've gotten jobs in finance like working on Wall Street because these students have advanced problem-solving skills. They get jobs in the aerospace sector and even in engineering roles. These are all jobs that actual astrophysicists and astronomers have talked about getting. And these are also jobs that some people just move on to after some time in the field because they wanted a change. So even if you can't find a research or tenured teaching position doing exactly what you want, it's very unlikely you'll become homeless or anything. You have other options out there. As a quick example, a man named Emanuel Derman was a physicist who did great work in the field of theoretical particle physics. He got his PhD from Columbia in 1973 and worked in the field for about a decade. But later in his career, he started working at Goldman Sachs, which is a finance company. He developed the Black German toy model, which is used for pricing of bond options and swaptions. So you see how this had nothing to do with theoretical particle physics? It was an entirely different field. and he is now known for being a quantitative analyst who applies math and statistics to financial problems. He had problem-solving skills and was obviously good at math, and what people don't realize is this leads to many different career options that aren't directly physics related. And I can't say this for sure, but I bet entering school he didn't know that he'd be going to Goldman Sachs within the next few decades and go back to teaching in financial engineering at university, which he did. So don't limit your career possibilities. This example may not be what you want to do, but it's not so black and white as to what you can get into. Now let's just sum this up before I talk about research and projects. If you're sitting there saying, I'm really interested in space, the universe, black holes, galaxies, relativity, etc., and just want to do research in that field for my career, and you're ready for a lot of math and hard work, then yes, go for physics or maybe astrophysics if it's offered, but just plain physics as an undergrad is a perfect way to start. Begin there and don't worry too much about 10 years from now. Then be ready to go into a master's and a PhD program. To optimize your success, you want to try to be the best student you can. You want to achieve high grades, and you also want to do research projects. Try to find professors who work in research you find interesting, and try to get on those projects with them even as an undergrad. This makes you stand out and also gives you experience in doing research, which is the majority of what you'll be doing as a PhD student. Then after getting your PhD, hopefully you can become a postdoc or postdoctoral researcher. This is basically a stage in your life between PhD student and professor where you often travel and just do research almost on your own, but you will have a supervisor. You might do short research projects and go through multiple postdoc positions while traveling until you land a tenured professor job. I read of one student who got his bachelor's in physics, then PhD in astrophysics, and is now a postdoc who does modeling of galaxies. I read of another student who got the same degrees and is now working with neutron stars and black holes for his postdoc. This may sound like a lot, but if you have a passion for physics, then you should love this. Doing a quick search, I found a postdoc job listing as a gravitational wave researcher at the West Virginia University Research Corporation, where you develop algorithms for gravitational wave development, which requires a PhD in physics, astronomy, or astrophysics. Now the pay for postdocs is typically pretty low, maybe between $35,000 to $45,000 per year on average for someone in the United States. But it can be higher, like between $60,000 or $70,000 a year if you get it at a national lab, but it just really depends. Physicists and astronomers have an average salary of over 6 figures according to the Bureau of Labor Statistics, but remember it is quite a process before you get there. The better student you are and the more you stand out, the higher chance you have of getting that job. If you don't land that professor or research scientist job at a national lab, be ready to possibly branch out to engineering, finance, software development, etc. But you should be able to find something. On the other hand, if you're sitting there saying that you like physics but you want to get your 4-year degree then enter the workforce, well, you can go into physics, but you should also consider looking into engineering, computer science, or something related, because that's often where physics undergraduates end up because they won't be doing research. Now let's move on to some cool examples of research that is going on in this field. The first thing I want to talk about is the James Webb Space Telescope. Whether you want to be a physicist or engineer, you will probably find this interesting. The James Webb Space Telescope is a NASA program, but the biggest company working on it is Northrop Grumman. This telescope is going to be the largest one ever put into space, and at 100 times more powerful than the Hubble, it is the most powerful telescope out there, and it will be able to see so far into the past that we will be able to observe the first galaxies being formed right after the Big Bang over 13.5 billion years ago. It's not so much a replacement for the Hubble telescope, but more of a successor that will allow us to see further into our universe and further back in time than we've ever seen before. The Hubble telescope is in Earth's orbit right now, about 375 miles from Earth. If something goes wrong with it, we can send people to go fix it. The James Webb telescope will be about 1 million miles away from Earth, or around 4 times further than the moon, so if anything goes wrong with it, it's space junk. It's too far for someone to go out to fix. The telescope will also unfold itself on its way to its destination orbit. The telescope is so sensitive that it needs to be shielded from the light from the sun, Earth, and even moon. And it will use a sun shield to do this that contains multiple layers and is equivalent to wearing SPF 1 million. So it's hard to imagine just how perfect everything has to be. Now, where is this telescope going to point? This is where the astrophysicists and astronomers and other scientists come in. Scientists from around the world are going to be able to use this telescope to discover new things about our universe. Proposals are being written by these scientists as to where the telescope should be aimed at that will prove most helpful and insightful, and this is going to be reviewed by independent scientists who will rank the proposals, and the best will be selected. They say this will open up an entirely new territory of astronomy, and the telescope is set to launch in October of 2018 as of today. And I'm going to start with dark matter and dark energy research going on at Stanford in the next video. So if you like this video, don't forget to comment, like, and subscribe, and I'll see you in part 2.